And that, Corporal Feebles, is the famous Niagara Falls. What do you think of it?
That's a lot of water, Captain. Where does it all go?
To the ocean eventually.
And where does it all come from?
The ocean.
Captain, are you feeling all right? How can all that water get back up on land after it runs down to the ocean?
Well, it's all part of what's called the water cycle, and, well, we'd better just dive right in. Most of the Earth's surface, almost 3/4, is covered by water. The Earth has an almost unimaginable amount of water, more than 1.4 billion cubic kilometers. Since 1 cubic kilometer equals 1 trillion liters, that's 1.4 billion trillion liters of water.
Wow, that's a lot of water.
And nearly all the Earth's water, about 97%, is in the oceans as salt water. So if all the Earth's water was contained in 52-liter bottles, only about 1/4 of one bottle would be fresh water. But that's still a lot of water, about 40 million cubic kilometers, or 40 million trillion liters. Water is the only substance on Earth that can be found in 3 different states at normal Earth temperatures.
I bet Washington is one of those states. Get it? Like in wash water.
Unfortunately, I do get it, Corporal. But you know very well the states I mean are physical forms. Water can be found as a liquid, of course, but it can also be found as a solid in ice and a gas in water vapor. Because water can exist in 3 states, it can be found almost anywhere. Most of the Earth's fresh water is frozen in the ice at the North and South Poles and in giant glaciers in other areas with cold climates. Almost all the rest of the fresh water is liquid water on the Earth's surface or in the ground. And just the tiniest bit of the Earth's fresh water is in the atmosphere as water vapor, such as found in clouds and fog. Let me ask you a question, Feebles. When I use the term water cycle, do you know what I mean? Not even close. That's not the water cycle I mean. The water cycle I'm referring to is the movement of water through its liquid, gas, and solid states around the world. Remember this, the Earth has pretty much the same total amount of water it had billions of years ago. It just keeps being moved from place to place and recycled.
Water should come with a label, made of 100% recycled materials.
You're right, Corporal. There's really no such thing as fresh water, only freshly recycled water.
Captain, what could possibly be big enough to recycle the ocean?
Is the sun big enough for you? Sunlight is energy. When sunlight reaches water, this energy is transformed into heat. We call the process by which water turns to water vapor evaporation. The heat provided by sunlight increases the rate of evaporation. Evaporation is the first step in the water cycle. The sun is, in effect, pumping the water into the atmosphere. Water evaporates wherever it contacts the air, from lakes and streams, from the soil, and even from animals and plants. But because the oceans are so large, most of the water vapor in the atmosphere comes from the oceans. It is estimated that nearly 1 meter of water evaporates from the oceans around the world each year.
Does the salt in the ocean water go up in the atmosphere too?
No, it doesn't. As the water evaporates, the salt is left behind.
So, if the oceans are always losing water through evaporation, and the salt is always left behind during evaporation, the oceans must be getting shallower and saltier all the time.
They aren't getting shallower because water is always moving back into the ocean through rivers and storms and other sources.
So it's a cycle.
There you go.
But what about the salt? Doesn't it build up in the ocean? Is the ocean getting saltier?
The fresh water that reaches the ocean from land always has a tiny amount of minerals or salts dissolved in it. There are chemical and physical processes that remove some of the salt from the ocean, but for the most part, the salt that washes into the ocean stays there. However, because the ocean is so vast, the increase in salt is extremely slow. The change in one's lifetime will be imperceptible.
So the atmosphere is like a giant sponge soaking up water vapor?
In a manner of speaking, and the drier and warmer the air is to start, the faster it will pick up water. Even more important, the warmer the air is, the more water vapor it can hold overall. Warm air can hold more water than cold air.
So when you can see lots of water in the air, like clouds or fog, the air must be really warm, right?
Sorry, Corporal, actually the opposite is true. When you see clouds or fog in the air, you're observing air that has cooled down since it took on water vapor. When water vapor cools and turns back into liquid water, it is called condensation. It's really very simple. Warm air rises, and as it rises away from the earth, it starts to cool. Now it can't hold as much water as it did when it was warmer. The water vapor starts to condense into tiny droplets. The water droplets are so tiny that they can still be carried in the air, but you can see them in the sky as different kinds of clouds and near the Earth's surface as fog and haze. When these droplets condense directly on the ground or grass, it's called dew.